All right, so the next couple figures that we are going to be looking at surface area for are cones and pyramids. And so, I mean, like when you think of a cone, obviously the first thing at least that comes to my mind is an ice cream cone, right? But this idea of surface area is always the same. It's how much would we need to cover all the outside area of your figure. And so in this case, and it's kind of hard to draw on a piece of paper, but a cone is made up of a circle, that's the base, and then that cone that's around the outside. So then kind of think if you go to an ice cream shop and like a piece of paper, comes around your cone, when you take that piece of paper off, it kind of looks like that. Okay, so we need to find the area of this piece and the area of this piece. We'll add them together, and that is going to be the surface area of your cone. So the formula for that, since the base is always going to be a circle, the formula for the area of a circle is pi r squared. But we're not going to multiply that by 2 like we did with cylinders because there's only one circle. The reason why we multiplied that by 2 was because a cylinder has that top circle and the bottom circle. Okay. All right, so now we have to talk about the area of this piece. So it's not like a triangle or a square or any other like shape that has, lines or segments as the parts of it. We've got this little slanted piece right here. So there's a special part of both a cone and a pyramid that we will need to use to find the surface area. And that's this piece that I've highlighted right here. Okay, so that piece of your cone and your pyramid is called the slant height, which we will abbreviate with like a lowercase l. I do cursive, so it doesn't look like a 1 if I just draw like a straight lowercase l. I'm not going to use S because that's how I represent surface area. So I don't want to get those two variables confused. And again, it's called the slant height because it's the slanted height of your cone. And so there are times where we might need to also incorporate the actual height of the cone. So remember, just like the height of like a trapezoid or a triangle, the actual height is the perpendicular distance from one side to the other. So what happens is when we draw in the actual height of the cone and then the radius of the circle out to the side, we have formed a right triangle with the slant height. And so we may be needing to use the Pythagorean theorem if we need to figure out what that slant height is. Okay, and so the formula for this part of the cone, kind of the wraparound piece, is pi times r times your slant height. And so when we add those two together, that is going to be the total surface area of your cone. Okay. And so we always need to make sure we find the radius and the slant height. If we know both of those things, then we can go ahead and find the surface area. All right, so just like we did with cylinders, we're going to be working on finding the exact and the approximate answer. So exact means you're leaving pi in your answer. The approximate answer means you're rounding your decimal. Okay? All right, so here is my first cone right here. And again, the information we need are the radius and the slant height, which I know in both of these. We don't need to know the height of the cone when you're finding the surface area. When we go to talk about volume, we'll need to know the height for that, but not for surface area. So now I can just go ahead and substitute everything in. So again, the area of the circle is going to be pi r squared, And then the cone, the outer part, is pi r L, which is 6. All right, so I'm going to find the exact answer first. So that's going to be 16 pi plus 24 pi. And when I add those together, that gives me 40 pi inches squared. Okay, so remember, just for the sake of consistency, we're going to be using 3.14 to approximate pi. So the approximate answer is going to be 125.6 inches squared. So here's my exact answer. Here's my approximate answer. Okay. All right, so now let's look at this next one. All right, so here is the base of the cone. There's the circle. There is the outer part. So it looks like I'm given the diameter. So the first thing I'm going to do is cut that in half to get the radius. So 11.5 divided by 2 is 5.75 centimeters. Okay. All right, and so then this 15.2, that's pointing to the height of the cone. So I know that this is a right angle since that's the height of the cone. So now I am going to need to use the Pythagorean theorem to find the slant height. So I've got my two legs. I'm searching for the hypotenuse, the side across from the right angle. So 15.2 squared plus 5.75 squared equals c squared. All right, so then, oops, what did I accidentally, an extra plus sign. So I'm gonna get 264.1025. I'm not gonna round that yet. I don't wanna round until the very end. We're trying to keep our answer as exact as possible. So I am gonna have to round that one. That's didn't come out as nicely as I would have hoped, but I'm gonna round this part to the 100th. The farther you can round out, the more precise your answer is gonna be, but I'm just gonna keep it 16.25. That way, when we do find our exact answer, the decimals aren't gonna be quite as long. Okay. All right, so now that I've got my slant height, I can put everything into the surface area formula. So pi times r squared plus pi times r times my slant height. Again, we're going to find the exact answer first. Keep pi in there. So oops, I typed the wrong, 5.75 squared, that's what I want. So 33.0625 pi, and then 5.75 times 16.25 is going to be 93.4375 pi. And then when I add those two together, I get 126.5 pi centimeters squared. That's pretty close to that approximate answer. All right, so there's my exact answer. Again, that has the pi in it. And so now I'll take that and multiply it by 3.14 to get my approximate surface area. Okay. All right, so the only extra work you should ever really have to do when finding the surface area of a cone is the Pythagorean theorem if you need the slant height. Like in this one, we did not have to do any extra work because the slant height was given to me, okay? All right, so that is a cone. Oh, now we're going to talk about a pyramid. And we are going to approach pyramids kind of like we did with prisms. So we're going to think about each face, so the lateral faces and the base. We're going to find the areas of those pieces, and then we'll add everything together. So we kind of lump like pyramids and prisms, like that, those methods together, and then cones and cylinders, just because of like the common like circular piece to it. And so one thing that we're going to be focused on, all of our bases that we are going to be talking about in this scenario are all going to be regular bases. Okay, so remember from last chapter, that word regular means that all angles and sides are congruent. So we are only going to be focusing on like square bases or equilateral triangle bases, things like that. Okay, so we're not going to make it too complicated. So if I were to take this pyramid, so I see that it has a four-sided base. So again, we are going to treat this as a square. If we had been in class, we would look at like rectangles and things like that. So we would have done a little bit harder pyramids, but again, we're just trying to get the general idea across here. So if I were to make the net of this pyramid, so remember the net means that we're taking it apart. So we would have this base, and then we would have these four triangles on the outside. I know you guys, I'm not an artist at all. So if I were to take like all of these triangles and like bend them up, that's how the pyramid would be formed. So when I am finding the surface area, we are going to take the area of the base, whether it's a square, a triangle, or whatever, and then we are going to add the area of the triangles. Now, because our bases are regular, that means all four or three, if we're looking at a triangular pyramid, they're all going to be congruent triangles. If we were looking at non-regular bases, the triangles would not be congruent. Okay, but all four of these triangles are congruent triangles. Okay. All right, and so in terms of the parts of the pyramid, they're similar to a cone. So there's two heights of a pyramid. There's your height that goes straight down to the center of your base and creates that right angle. So that is the actual height of your pyramid. And then you've got this right here. So the slant height is a little bit different. It's not like the sides of your pyramid like it is with a cone. The slant height of a pyramid is the height of one of the triangles. Okay, it still creates that like inner right triangle with the height. But this right here, that's going to be our slant height. So again, the slant height of a pyramid is not these sides, it's the height of one of the side triangles. And so that is going to help us when we're like finding the area of those triangles. All right, and so if we are looking at this one right here, so if I kind of just like write out in words what I'm going to need to do to find the surface area. The base has four sides, so I know that it's going to be a square. And the formula for the area of a square is base times height. Okay, so that's the base. And then since the base is a four-sided figure, that means I have four triangles. So I'm going to take 4 times the area of the triangles on the outside. They're all congruent, so the areas are all going to be the same. So what sometimes is easier for people to like visualize is to draw out two of the parts separately and then label what you know about it. So there is my base. So that's going to be 11.2 and 11.2. Okay. All right, and so now if I draw one of the lateral faces, the base of that triangle is also going to be 11.2. It's the same as the side of the square. And then the slant height right here is the height of your triangle, and that's 17 millimeters. So I don't need to do any extra work before finding the surface areas. I know all the information I need to find the area of the triangle, and then multiply that by 4, and then the area of the base. So I am good to go here. I'm just going to substitute everything in. 4 times 1/2 times the base times the height. All right, so 11.2 times 11.2 is 125.44. And then 4 times 1/2 times 11.2 times 17 is 380.8. So again, that is the area of the base. This is the total area of all 4 triangles on the outside. So my total surface area is going to be the sum of those pieces, which is going to be 506.24 millimeters squared. Okay. All right, so this one right here is going to be a little bit different. And so I gave you guys a little bit of a break from the special to right triangles. We're going to be bringing them back here because I can see that this base right here is a triangle. And since I told you that we are only working with regular bases, that means that all 3 sides are going to be 8 centimeters. So if I kind of lay out the surface area like I did in the other one, I've got 1/2 base times height. That is the triangle, that's the base. So I'm going to have 3 lateral faces coming off of these 3 sides. So if I were to draw the net of this, I'd have a triangle here, here, and here. So I've got 3 triangles that I also need to find the area for. So even though it's the same formula, because we're working with a triangular base and triangular faces, the parts of these will be a little bit different. Okay, all right. So the length of the base, right, if I have to find the area of this, is going to be 8 centimeters. So I know that part, but I don't know the height. Okay, so I'm going to draw that in. Since this is an equilateral triangle, that height is going to cut the base in half. Since it's an equilateral triangle, I know that that angle is going to be 60 degrees. So that makes this my short side. The long leg is always radical 3 times as long. So the height of the base is going to be 4 radical 3. So the area of my base, if I'm finding the exact answer first, just like we did with cone, so 1/2 times 8 times 4 is going to be 16 radical 3. So now I need to find the parts of the lateral faces, which are these guys right here. So again, the 13, that is not the slant height. That is not the part that I need. if I were to draw this triangle out separately, I should have done this. I'm going to do that down here. This part is 13. So I'm drawing that right triangle. Now, the faces are not equilateral triangles necessarily. They could be, but we know obviously they're not here because I've got 13 and 8 right here, so they're not the same. So this is not a special right triangle. This still, however, the height will cut the triangle in half since all of the faces are isosceles triangles. So I'm going to have to use the Pythagorean theorem. Sorry, can't talk today. Use the Pythagorean theorem to find the slant height, which is the height of the lateral face that you need in this formula. All right, so I would do a squared plus b squared equals c squared. 169 is 13 squared. When I subtract 16 from that, I get 153. All right, and I'm almost positive 9 goes into that. Yep, 17 times. We're going to simplify this radical to get our exact answer. So the square root of 9 is 3. And then that 17 would be left under. I don't know if you guys know this or not, but a little trick to figure out if your number is divisible by 9 or not. Like you might have been like, how does she know that 9 goes into that? If you add the digits of any number together and they equal 9, then 9 will go into it. So if I do like 9 times like 23, 207. So if I had gotten that, all you have to do is add the 3 digits together. If they add to 9, then 9 goes into it. So like all these weird numbers like that. So 531, 5 plus 3 is 8, 8 plus 1 is 9. So I would know that 9 goes into that. So when you get these like kind of weird looking, I shouldn't say they're not weird looking numbers, they're just not as common. That's a quick way to see if 9 goes into it. Little trick. And so that would be our slant height. And so that means that when I go to find the area, so I have 3 of these triangles, so 1/2, the length of the base is 8, and then we just found the height to be 3 radical 17. So just like I did here, gonna multiply like the number parts together. 3 times 1/2 times 8 times that 3 on the outside is going to be 36 radical 17. Now, since these radicals are not the same, we've got radical 3 and radical 17, we actually cannot add these two together to make them one radical. So this sum right here would be your approximate answer. I'm sorry, your exact answer. We haven't rounded anything yet. And so now I'm going to go ahead and type this in my calculator. So 16 radical 3 plus 36 radical 17. That is going to be my approximate answer. 176.14 centimeters squared. Okay. So again, there could be some extra work going in here. Once again, if we don't know the height of the lateral face, that's where the Pythagorean theorem will come in, either like this when we know like this side, or in this one in the square pyramid, if I had maybe known like the actual height, this would still be considered the radius, so we would cut that in half, and then you would do the Pythagorean theorem to find that slant height. Okay? So kind of like yesterday's homework, today has 2 cone practice problems, 2 pyramid practice problems. If you have any questions, just let me know.